by now you all started to work on something. I mean, you have some idea in which direction you have to go, right? It's not like yesterday. So you all are working on something. Is it okay? I mean, you are working on something, right? It's not that you are just sitting blank. Is it the case now? Answer. Okay, so you are going towards some direction, right? Maybe yeah, no answer. I'm asking a question. No,
Be honest.
Smile. Just tell. I mean, are you going to some direction, or you just maybe trying to find out something, and still you don't know where to go?
No,
So the mentors, they're working with you, right?
yes.
All of you.
I'm trying to find my direction.
Okay, that's also a good thing. Right? You're trying. And what about others? Nihal, Sandeep. Yeah, I'm correct this time. So you're getting some direction, or still you're struggling to find something?
Yes.
Okay, so why I'm asking this, because now we are going to have, this is a writing session by the way. So I will show you some presentation. I mean, I will show you how to present data, because many of you are doing some experiments, and when after collecting the data you need to present it, right? How do you do that? So that will be one thing, and also some of you are doing some theoretical theoretical simulation probably. So for them also, how do you write an equation? How do you use LaTeX to write an equation? So today I will talk about that, and with me you will also people who are doing some experiment. Maybe you can use your data to plot and show that or understand how to plot. And the people who are using theoretical simulation, you can also write some equations which you have already learned. So maybe if we start from the plot, like simple linear plot. So while plotting, suppose if you have what things. So you might have a set of parameters on what you are working on. Like maybe if I talk about Anupam, so you have some parameter like frequency and some parameter like time, like two parameters. So you all who are working on experiments, you might have some parameters like this, and you will have certain values for one parameter and a corresponding value for the other, right? So if you want to plot that in a 2D plot, how will you do? So what do we mean by 2D? Generally 2D is two-dimensional, right? So one dimension, suppose if I represent this x and this direction minus x, and here if you go minus y and y. So this is called 2D because here one dimension is represented by this axis x and another dimension is represented by another axis y. So if I take that example, Anupam's example, suppose frequency, if I take, I want to plot that with respect to time, how frequency is changing, suppose. Because you are collecting data, when you want to talk to somebody, how do you communicate? You cannot say that I have collected this frequency and at that time, this frequency at that time, and people will not understand. You have to give some kind of overview what you have done, and that we can do through the data representation. So for that, actually the plotting is important. Suppose if the time is there, suppose you will have several axes and several data points. Suppose 1, 2, 3, 4, 5, 6, 7. If I take, and maybe these all are in seconds. Suppose. Okay, and it's very important whenever you are representing the parameters. It's very important to write the unit because each parameter will have different unit. Unless you write the unit, the graph doesn't make any sense. Suppose if I do not write the second, what do you understand from here? 1, 2, 3, 4, 5, 6, 7. You don't actually understand. It can be length, it can be time, it can be weight, anything. You do not know that. So it's very important to write the unit. And in this axis I am representing frequency. Okay, so maybe frequency unit I'll give hertz, and so maybe here 100. Okay, if I take suppose some values, maybe 100, 200. Is it visible by any chance, or it's very small?
Visible.
400, 500. And as I told, that for each values in the x-axis, you should have a value in y-axis. Otherwise, you cannot do this kind of linear plot. So suppose I have a, maybe the frequency suppose is increasing. So maybe then for 1, you have a frequency here, 2. Okay, let me explain you again. Just let me. 500, and then 1, 2, 3, 4, 5, then 6, and then 7. Okay, so suppose we have done one experiment and you see at 1 second you are getting 100 hertz, and at 2 seconds you are getting 200 hertz, and 3 seconds you are getting 300. Like that, if you increase the second, you are getting different frequency, and these are called data points. Each point, these are called data points. So it's not necessary that you have to always connect them with the straight line. That depends what kind of fitting you will do. That always depends on. You always have to have a understanding whether the fit, whatever you are doing, is it realistic or not. Because sometimes it's not very much realistic to go for a straight line. Then maybe you have to go for some non-linear plot, like exponential or some other kind of non-linear plot. But here, if we see that if we connect the points, do we get some pattern, some known pattern? Like our mind, it always tries to get something in the simplest form, right? And what is the very simplest form of maybe curve, I'll say. What is the very simplest form of curve? What do you think? Like if I tell you, if I give you certain number of data points, and if you have to tell me, okay, these two parameters are behaving like this. So what will be the best way to think? And my question is getting clear? Okay. Yes. So actually, what I was trying to tell, if you have to tell somebody how the two parameters are related, generally you will go for the simplest one, that is a linear form. If you suppose take a very complex non-linear form, it's very difficult to visualize or understand. So whatever is the data, we always try to make it in linear form or straight line form. So maybe from this data points, if I see here, so here maybe I can fit a straight line up to this much, but here these points are not coming. So if you are doing some experiment, and if you see that some points are maybe here, it may happen that every time you will not get some kind of data points in a proper nice straight line. So then what do? Sometimes we may have to, you should have that understanding that, okay, if I give these 2 points, whether I am able to still explain the behavior of my parameters or not. It's not necessary that every time it will be a nice one. Most of the time it has been seen also for the researchers that they try to make some fit purposely. Maybe the data is not properly aligned as a straight line, but sometimes they purposely make some manipulation and they try to highlight. That is not at all welcome. Whatever you are getting, you should have that. And why actually these 2 points are not in line? Maybe that can be a question. Okay, so then you have to be logical to say that maybe there is some kind of instrument error, or maybe while doing some measurement there is some kind of influence. That kind of logical answer you should have. Am I making sense?
Guys,
Or I'm going in different direction. What do you think?
it's slightly on different direction.
Different direction.
Yeah.
Okay. Maybe coming back.
Should we with an example or something?
Example of this kind of.
Some taking some data and then.
Yeah. Suppose if I open a Excel sheet and then maybe I open a new one. So are you all familiar with Excel? So maybe I can plot here. Suppose this is one parameter. Maybe this is A and B. So in A I have some values maybe. 2, 4, 5. Maybe let me take 7 values and I have something. And then maybe here if I say some random values. Okay, and if I try to plot it, with this plot, right?
Insert graph.
Insert graph. Where is graph? 3D map, no. Line, probably. Or plot.
Yeah, it is. There is, I think line.
Line. Will it give this?
Yes.
Okay. Perfect. Observation reference on value.
So you can select the.
Or does it make this?
The second option.
This one?
Or the second. Yeah, that's also fine.
Yeah. If I take the first one, the scatter. So actually, what you see here. Suppose this is my x. 2, 3, 5, 10. Where do I have a data point? 12, 8. So this is my x. And this is my y. So you see I have given some values for x and y and I have the data points what actually I was trying to draw there. And now, do you see any definite pattern there? We do not see any definite pattern. But if there are options also, if I want to make them connected, I get some this kind of pattern. So is it a very good, I mean, if somebody asks me that what do you understand from the x and y behavior and what is the problem, linking, what is the, how y is dependent on x. So from this kind of curve, is it very easy to define? It's not very easy, right? Because, but if it's a straight line, it will be much easier for us. So we always try to find that which equation or which kind of plot we should use so that it will make a straight line. And suppose if you have this values what you see in x and y, and these are very small values. So suppose I have x values, y value is fine. Suppose in x I have here 10 power maybe if I want to plot this kind of data, suppose, insert.
Scale.
Yeah, I think it's all there. Suppose if I go for snapshot. So do you see the x values? The first one is 2. The second one is almost 900 times more. And then the third one is 1000 times, 6,000 times. So you see there is a huge variation in the values in the x-axis. And when you see the plot, you see here it is 2 somewhere here, right?
Yeah, everything is close to 0.
Yes. And then 900, that is also somewhere here. So it looks apparently like 2, 900, 600, there is no difference. Can you make out any difference from there, from the graph, that the difference between 2, 900, 600? But you know there is a difference, right? So if you get this kind of variation, huge variation, then in range, then what should you do? Log. So if I go for a log plot, what will happen? And do we have a log plot option here?
I think Dr Moumita have option.
Okay.
On the graph.
On the graph, right click maybe. Then, so, but maybe
No.
access for
Format plotting.
format plot area maybe. Format plot area. Format plot area.
In the same thing.
In the drop down menu, yeah. Down, last.
No, this is a color and.
No, but select the axis. Select the axis.
Bottom.
Yeah, one axis. Yeah.
Yeah,
All right.
Now it's there on the right side.
Right side, text option,
Format axis.
axis option,
Yeah.
There are 4 things, right?
horizontal, vertical, axis, measure, guideline.
There are 4 things, right?
Wherever.
4 symbols.
The 4 symbols. After that, yeah.
Here.
Distribution.
Is it linear?
No.
Next one.
Axis
options.
Possibly.
Log.
Axis, automatic, vertical, display log.
Yeah.
Yes, now you see. So I have changed the x-axis, that linear x-axis, to logarithmic axis. So what do you see here? Now actually you can see here the first point is 2. And the second one is 900. So that also you see here. You can clearly see the data points. So you have to be, while choosing what kind of plot you are doing, you have to understand that it should be representable properly. Otherwise, suppose if you have used only the XY plot, the linear XY plot, then actually you do not have more information. You cannot extract information. So you have to understand that. And also, sometimes when you are taking, suppose when you are using some kind of waves or signals, then whatever you are capturing, and whatever output you see, you think that it is your output, but many of the cases it is not that thing. Because when you are using some instrument, that instrument will have some own noise superimposed with the output. And because of that, what output you get, it's not the actual one. So what you need to do, you need to do some baseline correction for that. That means you have to understand what is the behavior of the instrument, or what is the behavior of the instrument when a particular known input is given to the instrument. And then you can subtract that from the final signal what you are getting. So if you can do that, then you get the proper output what you should get. So you should always keep, because I have seen some of the reports where these kind of things are not done. And so maybe you are very curious to see the output that we got some different kind of thing, but it's not maybe, most of the time it is from the system you are getting the output. And that's why you are getting a very different kind of final signal. And so one thing I wanted to tell them.